In today's issue of Geometry, we're going to talk about angle relationships. So, how do you feel about angles? All right, so the first relationship we're going to talk about are with pairs of angles are adjacent angles. And these are two angles that lie in the same plane. They have a common vertex and a common side, but no common interior points. Okay, so in this first drawing here, I have angle 1 and angle 2. And what you'll see here is that we have a common vertex right here, okay? Common vertex with point A. We also have a common side here, right? We have this common side, all right? That would be ray AC. And you can see here we have no common interior points, right? So no points here are in here, and vice versa, right? Which means just switch it around. If you look at angle BAD, right, which is this whole entire angle here is angle BAD, okay? These are not adjacent angles. I mean, and the reason why, let's go through it. Does it have a common vertex? Well, yeah. Does it have a common side here? Yes. But we have all these common interior points, all right? And we have this here overlap, right? This is the overlap. This is where these common interior points are shared by both angles. So those would not be adjacent angles. Okay, a linear pair is a pair of adjacent angles with non-common sides that are opposite rays. Okay, so we would have, this is a non-common side, and this is the non-common side. They're in different colors, and they are opposite rays. So angle 1 and angle 2 is what we would call a linear pair. Something to make note of, all linear pairs add up to 180 degrees. Okay, a vertical angle is formed by two non-adjacent angles formed by two intersecting lines. So we have these two lines in here, and we look at angle 1 and angle 3. Both of those angles are what we would call vertical angles. All right. The only thing they have in common is the vertex. They're formed by two lines, and the only point they have in common is the vertex. We can say the same thing about angle 2 and angle 4. Those are also vertical angles. They are not adjacent, and the only thing they have in common is that vertex. Okay, so those are relationships that angles can have based upon their locations, right? Based upon how they're set up with each other. But angles can also have relationships based upon their values and what they add up to. So a complementary angle isn't a pair of angles, or complementary angles are two angles with measures that add up to 90. These angles can be in the same plane, they can be in different planes. It doesn't matter where they are. If they have values that add up to 90, they are complementary. If they add up, if one angle is 60, the other one's 30, they're complementary. We talked a little bit about linear pairs of angles. Well, those are also supplementary. So we would call those supplementary. So those are two angles that have a sum of 180, right? And here it says the angles in a linear pair are supplementary. A way to remember this is that C comes before S in alphabetical order. 90 comes before 180 in numerical order, right? So complementary comes with C, goes with 90. Supplementary S goes with 180. Okay, the next type of lines we want to talk about, because they create very special kind of angles, are perpendicular. So any line segments or rays that form right angles are perpendicular. If you remember, right angles are angles that equal 90 degrees. So perpendicular lines intersect to form four right angles. Perpendicular lines intersect to form congruent adjacent angles. The angles that are next to each other are going to be congruent. Segments and rays can also be perpendicular to other segments or rays or lines. Okay, and we put the right angle symbol, which is the little box in the angle, in figures to indicate that the lines are perpendicular. So here we have a drawing of two perpendicular lines, L and M. So the symbol for perpendicular is like, it looks like an upside down T, right? It's basically two segments that are perpendicular. The way we would read a statement such as what we have here is line AD is perpendicular to line CB. If we look at our drawing, we have line L is perpendicular to line M. Notice, how do we designate this? We designate it with the little box. We only need to draw one of the little red box there. It doesn't have to necessarily be red, but if we have that little box in the corner, that designates in that drawing that those two lines are perpendicular. Okay, so we need to discuss something called assumptions. And assumptions are things that we can make if based upon certain logical and reasoning rules. Okay, we cannot base anything upon what we think it might be. Okay, so these are the things. Let's talk about this. Here's this diagram, and if I look at the things that are, we can't assume, we can say, hey, all these points are on the same plane. I can assume G, H, and J are on the same line. They're drawn that way. We're going to assume that. We can assume that ray HM, ray HL, ray HK, and line GJ all intersect at point H. We can look at the diagram and we can say, hey, H is between G and J. We can also say that L is in the interior of angle MHK. We can further state that angle GHM and angle MHL are adjacent angles. We could pick any number of angles in here, but we'll pick these two. We can say angle GHL and angle LHJ are a linear pair. And because they're linear, we know then they're supplementary. We can also look at angle JHK and angle KHG, and we can say that Those angles are supplementary. Okay, looking at this drawing, we cannot assume that ray HM is perpendicular to ray HL. Okay, we don't know. Okay, so we have to just assume, right? We can't assume that. We have to look at it and go, nope, it looks close, but it maybe not be. All right, it's really difficult to tell. It's got to be 90 degrees. It's very, very difficult to look at a drawing and say, well, this is 89 and this one is 88 or whatever. If you're very close to the angle, it's very difficult to tell. We cannot assume congruence unless it's marked. So any of these angles here, JHK congruent to GHM, angle JHK congruent to angle KHL, angle KHL congruent to angle LHM. We cannot assume that unless it's marked. Okay? We can't say, well, it looks close. Doesn't matter if it looks close. It's got to be marked. Or we have to have a numerical value that tells us this. These segments that are all listed here, okay, while they all look pretty close to each other, we cannot make assumptions that they are congruent. So all those assumptions, some can be made, some can't. Okay, so here we are with an example problem. Find the measures of two supplementary angles if the difference in the measures of the two angles is 18. Okay, so one angle, we're going to always assume one angle is smaller and one angle is larger. So if we say here, looking at this, is that, okay, angle A is X. That appears to be the larger angle. So angle A is equal to X. We know that angle B, that there's a difference. So we know that angle B, well, if angle A is bigger, then angle B is going to be equal to X minus 18. We're going to figure, hey, if there's a difference of 18, that means angle A minus 18 would be angle B. So now we can put together an equation and substitute with it. So, and do some algebra. So we're going to say angle A plus angle B is equal to 180. And the reason we can do that is because of this, right? These two angles are supplementary angles. So we know they add up to 180. So from here, what we're going to do is we're going to use what we've learned and say, okay, if angle A is equal to X, we're going to substitute X plus angle B is X minus 18. And that is equal to 180. So we substitute here. So now we just do some basic algebra. X plus X is 2X minus 18 is equal to 180. We're going to add 18 to each side of this, and I'm going to end up with 2X is equal to 198. If I divide each side by 2, I know that X is equal to 99. So angle A is X, that's going to be 99. Angle B is going to be 99 minus 18. So that's going to be 81. And to double check over here, I can look at this and I can say 99 plus 81. Does it add up to 180? And it does. Okay, now we have two complementary angles and we don't have a diagram. And this is going to happen quite often. So what we're going to do here is we're going to take this information and develop our equation. So I'm going to assume there's a smaller and a larger, right? So the smaller angle, we're going to say for discussion, right? So we're going to call that angle S and then angle L for larger. Okay, so we're told that the larger angle is 12 more than twice the measure of the smaller. Well, we don't have any description of the smaller. That's the one you want to have X. So we're going to say the smaller angle is X. The larger angle is 12 more. Well, we're going to add 12 more, right? Plus 12. Oh, hold on a second. Not plus 2, plus 12. Then twice the measure of the smaller angle. Well, twice the measure would be 2x. So now we can come over here and I know angle smaller plus the angle L, the larger, is equal to 90. Right? Because they're complementary. How do we know? Because they're complementary. Right? Okay. So angle S is X. Angle L, the larger one, is 2x plus 12, and that's going to be equal to 90. So x plus 2x, that's 3x, plus 12 equals 90. I'm going to subtract 12 from each side of the equation. So I end up with 3x. 90 minus 12 is 78. Divide everything by 3 to get x, and x is equal to 26. So the measure of my smaller angle is 26. The measure of my larger angle is 2 times 26, which is 52. 52, right? Is that correct? Let me make sure. Yeah, 2 times 26 is 52, yes. Plus 12 is 64. Let's check our work. Is 26 plus 64 equal to 90? And yes, it is. So this checks out. So the measure of our angles is our 26 and 64. Okay. Okay, now find the values for x and y so that line PR and line SQ are perpendicular. So what does this mean to do? Well, the first thing I like to do when I get a problem like this is I'm going to put in that it's perpendicular. I'm going to draw my perpendicular sign or my symbol on one of the angles. I know then that all of these angles are equal to 90 because there's going to be 4 perpendicular. Excuse me. There's going to be 4 angles on the diagram that are all equal to 90. So I know that these 2 angles here, this angle value here and this value of this angle here, they have to add up to 90. So I'm going to set up my equation. 2x plus 5x plus 6 equals 90. So 2x plus 5x, that's 7x, plus 6 equals 90. Subtract 6 from each side, I've got 7x is equal to 84. And then I divide by 7, and I end up with x is equal to 12. I can plug that back in here and I can solve for this, right? 2 times 12 would be 24, right? 5 times 12 is 60 plus 6, that's 66. And I know right off the bat 24, oops, excuse me, not 60, 66. Yeah, there we go. So 24 plus 66 is 90. Let's do our y value now. I don't have to mess around. I can just take the y value equation, 4y minus 2, and that would be equal to 90. So subtract 2, add 2 to each side, and I get 4y is equal to 92. Divide each side by 4, and I've got y is equal to 23. Right? Let's check it. Okay, so 4 times 23 is 92. Subtract 2 is 90, right? So go ahead and when you're done with this, we circle our answers. Okay, now we're going to play this little game called Determine Whether Each Statement Can Be Assumed from the Figure. Okay, and we need to explain why. So, number 1, angle KHJ and angle GHM are complementary. All right, so the thing you need to do here, you need to mark up the diagrams, right? So KHJ, that's this angle right here, okay? And angle GHM, okay? Well, are they complementary? I don't know. There's no value there. Now they're congruent, but I cannot assume they're complementary. So therefore, the answer is what? No, we cannot make that assumption. Okay. Okay. Next question. Can we assume that angle GHK, which is this angle right here, and angle JHK, which is this angle right here, are a linear pair? And we can, right? Because we can look at this and we can deduce or we can assume from the drawing that this ray here, ray HG, is opposite to ray HJ. Okay, so this one is yes, we can assume those are a linear pair. Okay, next, ray HL is perpendicular to ray HM. Well, if we take a look here on this drawing, we can see this little red box designates right angle. And since perpendicular lines form right angles, we can state then that this is a big yes. All right, next one. Angle GHL angle GHL and angle M, let's go with a different color here, MHK are supplementary. And the answer is no, we cannot make that assumption. We don't have any information. We know this piece is 90, but we don't know what this one is, and we don't know this value. And I will tell you, we can also state for sure that because this angle here is greater than 90, and this angle here is also greater than 90. Since both of those are greater than 90, it's going to add up to more than 180. And therefore, they can't be supplemental. So that's a big fat no. Okay, our final question here on assumptions. Angle GHM, hold on a second. And angle MHK are adjacent angles. Well, they have a common vertex, they have a common side, and no common interior points. So by definition of adjacent angle, we can state with certainty that yes, we can make that assumption that they are adjacent because in the drawing they're adjacent. We can assume those are true. We can assume that.